See this?
Yeah.
Okay, we have to go factoring this. So whenever you're doing factoring, always look for the greatest common factor first. So we know that actually 3 will come out of both 48 and 3, and I can take x out of both of these, right? So that's our first step. So we end up with y equals 3x, and then we divide by it. So I have x squared
Minus 16.
16, perfect. Okay, this is a difference of squares.
Right.
All right, so you recognize that?
Yeah.
Just find the square root of both, and we split it into 2. So we have y is equal to 3x, x minus 4, x plus 4. Okay. So when we go to graph, this, we have to find out our x-intercepts, right?
Mm-hmm.
Our x-intercepts are always when y is equal to 0, right? So we know that we're going to have 1, 2, 3 of them, and the coordinates are going to be some x-coordinate, y 0, that'll be our first one. Our second one, same idea, y 0, and same idea, y 0. So in order to solve them, I set each of these little terms, this term, this term, and this term, all equal to 0, and solve for them. So 3x equals 0, x plus 4 equals 0, x minus 4 equals 0. No, that's a bracket. There you go. Equals 0. In this case, x is
0.
Yep, x is
Negative 4.
and
The way she taught us to find the y-intercept is multiply.
okay, so we have our x-intercepts. We can quickly plot them. What were they? 0, negative 4, and 4. So simple. X-intercepts. 1 is at 0. 1's at 1, 2, 3, 4. Negative 4. So this one is negative 4.
But do you have to set it to 0, or can't you just take it out of the bracket? That it's the opposite sign.
Yeah, you can do that. But the reason you set it equals 0 is if at any point you're factoring and say you get something like 3x minus 2. Right? I know you can probably do this in your head quickly, but
and then it's 2 over 3?
Yeah, it's going to be 2 over 3.
Okay.
Yeah. If you can do it in your head, go for it. But it's just the way to show it. That's why you set it equal to 0. Okay. So we have those. In order to find a y-intercept, the difference here is before to find the x-intercept, we set y equal to 0. To find a y-intercept, we set all the x's equal to 0. Okay.
Yeah, so that's how I got negative 16.
Yeah, and that will work every time. So in that case, we have y is equal to 3x. I'm just going to rewrite the equation. Plus 4 minus 4. Well, if we set all the x's equal to 0, yeah, we'll get 3 times 0, which is 0.
4.
Yeah, positive 4. And 0, negative 4. Oh, I want to think really quickly about this. Okay, that's okay. So when we go to figure this out, 0 times 4 times negative 4, but because we got a 0, yeah, and you know what? That makes perfect logical sense because one of our x-intercepts was 0, negative 4, and 4, right? So that x-intercept was also our y-intercept. So we know we're going to cross there. Our coefficient was positive, right? And it's cubic, the original function.
Right.
So we're going from quadrant 2 to quadrant 4.
Wait,
I
what?
got that confused. Give me a sec. Sorry, it goes from the other one. 3 to 1. Yes, because we go in a positive direction like a linear equation. Okay, so it's positive, and what's most important, when we're passing our x-intercepts, these are all technically to the power of 1, so it's going to go straight through them. The only thing we don't exactly know are the turning points, but we know we're going to have some function that goes up like that, down like that. Right? So that would be the graph of 9a. All right, so we got to investigate f at x equals x cubed, or y equals x cubed, right? X value, y value. Normally do table of values in order, so let's say we're at negative 4 to start. It's as simple as y negative 4 cubed, okay? Because it's to the power of 3, 4 to the negative 4 cubed, negative 64. It doesn't even fall on our chart, right? We're only going to 10. 3 cubed, negative 27. Still doesn't fall on our chart. 2 That's going to help us out. So -2, -8. What about 1? Do you know what 1 will be? Yeah. Well, -1. That's what's important. And 1 with 1. What will 0 be? What will 1 be?
1.
2?
8.
3?
27.
Good. And 4?
64.
Good. Okay. So when you go to graph this, our original one falls to the origin at 0 and 0. It hits point 1 and point 1. And then it hits 2 and 8. And same with the other one, 2 and 8. So it's kind of symmetrical in that sense. That's that. There you go. Right? And because it's cubed, it really takes off fast as it goes up the chart. So we essentially end up like this, taking off, and then it cuts across and down. Okay? So that's our original function. When we're doing transformations, they had taught you before f at x is equal to, is it a you use?
Yeah.
Function, I don't remember, is
K.
it b or k? K? So you guys use k.
X minus D.
D?
Yeah, plus D.
Okay. So yeah, we
Would
know.
you have the same text? So wouldn't it be the same letter?
You know what? I still use H and K for the vertical and trans,
Yeah.
just because I know they're used to it from grade 10. Okay, so C is our up and down. Okay, this is transformation zone. This is a stretch, up and down, and K is horizontal stretch, and D is horizontal transformation. That's a lot of scribbling there. Okay. So you're familiar with all that stuff? Okay, so say we have an equation, and we'll just copy this.
When A is greater than 1, it's
All right, let's quickly go through what letters what. So what is our C?
-3.
Yep, and what is going to be our A?
8. -8.
-8, yep. And same idea with the other ones. D is going to be
-1.
and K.
1. Well, like, isn't it when you take it out, you say by a factor of 1, right?
Yeah, so actually what's going to happen in this one here? So say we were to take it out again, say we were to take out a half, our D isn't actually going to be 1.
It's -1.
I want you to think of this. So I'm going to isolate just the brackets right now. I'm going to talk about them. So you have a half x plus 1. Don't worry, you'll be okay. All right. We always want x. In order for, see how it's x plus d to be set up like this, we need the coefficient to be 1 in front of x. Okay? So for this coefficient to be 1, I actually have to take a half out. So when I take a half out, my k is still going to be a half of x. When I take a half out of here, what's going to happen? Do you know? Think of it as we're dividing by 1/2. So I take the number. So in this one, we did
Isn't it 0.5?
half x divided by a half, and the halves canceled out. In this one, we do 1 divided by a half. Okay? I know that looks confusing, but really what that says is 1 divided by a half.
Sure.
Yeah, it ends up being 2. If you remember the rules, we flip them, so we get 1/1 times 2/1. It ends up being 2. So I end up with x plus 2 inside. So my d is actually not 1. My d is actually 2. So we're just going to kind of rewrite that equation down here with the coefficient of x being 1.
So how do you know when to take it out whenever there's something in front of x?
Yeah, whenever there's a coefficient in front of x, you got to make sure that you factor out the coefficient, whatever it is, okay? 8, k is still going to be a half, you're right? X plus 2 in this case, cubed, minus 3. Does that make
I
sense?
get that wrong on like every test then, because I don't remember ever doing that.
It probably hasn't affected you too much on most of the things when you're going to shift it. It's only...
So if
It won't affect it for quadratic... Oh, no, it will affect for quadratic functions. It's just, you know what? Your teacher's probably already had it split for you on most tests. All right, so now that we've done that, we can talk about our shifts quickly. We know we're going to have a shift down 3 units, right? So it's not a vertex, but our middle point, right? It's going to go 1, 2, 3 downwards. So that's gone down 3. And we're going to go to the left 2, 1, 2. So our new kind of middle point will be here. Now, when we're finding our y's...
So, okay, you only apply D and C to that point?
Yes, I've only applied so far D and C. It's to the middle point. I've applied it to the middle point so I know how far to go from there.
So, like, on a test, what should I do? Should I just apply D and C first, and then...
I find it easiest to do that. You can, if you prefer, you can apply A and K first so that you end up with your stretches, however it's going to look. And then you can move the function to the left and down and just keep those stretches if you want. But then you have to move your specific points. I personally find it easiest to take the 1 point, move it, and then apply the stretches from there.
Okay.
So at this point right now, if I haven't applied stretches, so we'll keep it in blue, let's say. My next point would be over 1, up 1, because that's how far I went from here. Over 1, down 1, right? Over 1, down 1.
Sorry, what?
So from this middle point, I went over 1, up 1 on our original. Okay, so I haven't applied any stretches yet. Same with this. I went over 1, down 1. This is another coordinate we'd found. Remember when we were doing our table of values?
Mm-hmm.
-1 and -1.
Okay.
Essentially, it's because we went to -1 and we cubed it.
Okay, so now you're going...
Now we're going +2 cubed. Well, +2 cubed is 2 and 8, right? So from this point, I'm always starting back from my middle point. I go over 2 and up 1, 2, 5, 6, 8. Here's another point. Same idea.
Confused. We have to go down 3.
I've moved that. Consider this like a vertex almost.
Okay.
Like a vertex of a quadratic. Just this one's a cubic function. So when I go to redraw it, do you remember when we were doing quadratics earlier? And I'll just quickly do one. Say our vertex is here. A normal quadratic's over 1, up 1, over 1, up 1, over 2, and then you square it, so you go up 4. And then when you go over 3, you square it, so you go up 9. It's the same idea. The only difference is when we're going over, we're cubing it. So when I go 1 in the positive direction, 1 cubed is 1. So I go up 1. Here's another point.
But you don't apply any transformations after that?
No. I haven't applied stretches yet. I'm going to do that in a minute. I'm just kind of redrawing it so you see where we are. Okay? Then I go back to that middle. When I go over 2 from there, 2 cubed is 8. So I went up 8 units. So there's another point I got to cross. So I already know my function is going to go something like this heading upwards. If I were to go to the left, which is -1, -1 cubed is -1. So I go down 1. If I were to go 2 to the left, right, I go -2. -2 cubed is -8. So I go down 8. 1, 2, 3, 4, 5, 6, 7, 8. So I'm down here. So then as I connect this function, I end up like that. So if you notice, here's the key. Essentially, this vertex, if you want to call it that, it really isn't, but this middle point has gone down 3, like in our C. It's gone down 3 units. And it's gone to the left 2, because it's +2. Left 2. So you see how there's our new vertex? I still have the exact same shape. I haven't applied any stretches or compressions to this yet.
So what's that orange point? Like 0 and 0?
Yeah, that's right at the origin, 0 and 0. Because that was our original graph I drawn. The original graph would be
Okay,
what?
wait, so what's the new graph?
The new graph would be with the equation. So this equation for our original one is x cubed. The new equation...
Can you do it in a different color? Yeah. Sorry, I can't.
That's okay.
So why is it going through 0 and 0?
It's not. It's jumping up. I'm just not drawing it perfectly. It's...
How do you know how far it goes?
Well, I can only go as far as my graph. It's going to go off forever. Okay, so our new blue one.
No, I know, because, like, that's 2 and 8. That's what that was. But I don't get why they're going in front.
Let's do this. Let's do a new clean one. And then we'll come back to that. Maybe it'll make a little more sense to you that way. So let's do this. So, this function
just the
here.
way you drew it?
It might be the way I drew it that's confusing you. X cubed. I know that I have a kind of like our middle point at 0 and 0. Does that make sense?
Yeah.
I go over 1,
Mm-hmm.
and when I cube 1, it's 1. So I go up 1.
-1 and 1.
Yeah. So -4.
And then 2 and 8.
Yes.
And 2 -8. Okay,
Good.
I get that.
You're a genius. Let's do the next part here. All right. I'm going to go to draw this, connect the dots. Let's just work on transformations this time. I know my calligraphy isn't perfect.
No, it's just...
Let's say now we had y is equal to plus 3. Okay?
Mm-hmm.
So those are the transformations. We're only working with transformations right now. I didn't put any stretches. So we know this is going to be moving to the left 4 in a negative direction, right? And this is going to be up 3. Okay? So what I've done is I've taken this middle point. I'm just going to put the middle point in red, okay? Taking that middle point, and I'm going to go to the left 4. So I go 1, 2, 3, 4, up 3. 1, 2, 3. Here's my new middle point. Do you want to put it red too?
Sure.
Okay. The new middle point's red. I'm going to get rid of those steps I used.
Yeah.
Okay, so it's a little cleaner. So we have our new middle point. Now I draw the same shape. Just consider that the new middle point. So I go over 1. Remember how I went over 1? I would go up how many?
1.
If I go back 1, I'd go down. If I go over 2, I go up.
8.
Yeah, so 1, 2, 6, 7. I'd be up here. And if I go over 2, I go down.
8.
So when I go to connect.
And that's the same as taking each point and going up.
It's the exact same as going up 1, 2, 3. 1, 2, 3, 4. See how that worked? Yeah, they end up being the exact same. I'll do this one.
I feel so stupid because like we've been over this, but I just
That's
don't
okay. It's okay. It's every time you see a new function, it takes a while to wrap your head around how this function is drawn. Okay, so this is a cubic function. So the blue one was this equation, and the black one was our original. Okay. Now we got to deal with stretches. So we go back to that page. This one's messy. Let's start a new one. Okay, same question. Quickly, we already realized we had to take a half out, so it ended up being like this. Cubed minus 3, right? That was our new function. And I'm gonna. Do you want me to draw the original, or you okay with it?
Yeah.
Okay, let's just talk about the movement then. The original center is there. Left 2, down 3. That makes sense?
Mm-hmm.
So I go left 1, 2, down 1, 2, 3. So there's our new middle point. That makes sense? Okay. I'm going to draw the new one with just the transformations. So I go over 1, up 1, over 1, down 1. That makes sense? Mm-hmm. Over 2, up 8.
Yep.
Over 2, down 8, which I think took us off. Okay. So here's our with transform. That's better.
So it doesn't matter how you draw it? Like, that was what was confusing me. Like, okay. Could this have been drawn so that it comes up like that? Or, like, why is it going...
Why is it doing this, are you saying? Why is it going like that? Is that what you're asking at that point there?
Like, how come you're drawing it so that it's, still on the negative side of the x-axis?
Because it doesn't hit... This was our point here. Remember, that was one of the points we had? I knew it didn't hit till there, so I tried to stay as close to the line until there, and then it took off.
But if you're sketching it and you just drew it on...
If you went like this and came back, that definitely would be
No.
Okay.
Like, could you stay up? Like, can you stay on the point like that, or you just...
Oh, I know it's eventually... Oh, so you're asking, could you do this?
Yeah.
Sorry. Go like this, and then, like, kind of just stay up here?
I get it.
Up the y-axis? Is that what you're asking? Eventually, it's going to keep moving to the right. It's just the graph is extreme. It's very exponential. It's going to keep going higher and higher. So we try to do it gradually. It gets steeper and steeper. That's the idea to it. Okay?
Yeah.
That makes sense?
Yeah.
Okay. This is our A is -8.
Right.
So, first of all, if A is negative, what happens to this thing?
It's going to be flat.
Yeah, so it's going to be flipped. So in other words, I'll do the flipped version.
Wait, how are you doing the flip version?
Oopsie. Flip version, okay? Normally go to the right one, up one. Flip version is going to go to the left one, up one. Normally go to the left one, down one. What you're going to find is is just like this. Okay, that's what the flip version is going to look
But
like.
your middle point doesn't change.
Middle point staying the same. Consider it like a vertex of a quadratic. All right, that's where we do the flipping, is at that point. Okay, so our new one, we go over one, left one, up one, right one, down one. Kind of the opposite of what we were doing before. Left 2, up 8. So it's going to be it's going to be symmetrical. Down 8. So again, I'm already bad enough at drawing these. Try going the other way now. Like that. There you go, roughly like that. Okay, so now that's the flip version. That's just with A being negative. Now that it's stretched, remember that middle point's not going to really change. We're still staying at, consider it like a vertex. I go over 1. Normally I go up 1 or whatever number it is. You need to multiply that number by the absolute value of this, 8. So because we normally go over 1, up 1, I take that 1 and I times 8. So I go over 1, up 1, 2, 3, 4, 5, 6, 7, 8. So here's my first point. And my first point down is like down here. Okay, so our 2 no points, I'll do them in green. Here's one of the points. This one I go over 1, and normally I go down 1, right? But I have to multiply 1 by 8. So I go down 1, 2, 3, 4, 5, 6, 7, 8. So it's down here. So if you notice, this function here is stretched. It's much thinner than our blue function.